Fellow developers, welcome to day 4 of the 30 Days of JavaScript Challenge. Today presents another opportunity for us to tackle challenges and enhance our understanding of JavaScript concepts. Let's dive in and make the most out of this learning journey. Today's challenge says, write a function called createCounter that should accept an initial integer in it and return an object with three functions. The three functions are, the first one is called increment, that increases the current value by 1 and then return it. The second value is decrement, that reduces the current value by 1, then returns it. The third function is reset, that sets the current value to the init and returns it. So that is what the three functions will do, and there are some examples here. So the first example, it uses the value of init as 5. Then there are three calls made. The first call is call to increment, then call to reset, then call to decrement. So the expected output is, when you use 5 as the initial value and you call increment, it will return 6. When you call reset, it will return 5, because increment, the initial value is 5. When you increment it, it will be 6. Then you reset, it goes back to the initial value that was 5. That's why the second output is 5. Then decrement, it takes the current value of init, which is 5, then reduces it by 1, so it becomes 4. That's why the output is 6, 5, and 4. The same thing with the second example here. It uses init value of 0. When you call increment, it should be 1, because it will be 0 plus 1. When you call increment again, now a new value of init is 1, so it will be 1 plus 1, so it should return 2. When you call decrement, it will be the current value of init minus 1, so it's 2 minus 1, so it will go back to 1. And when you call reset, it goes back to the initial value, which was 0. Then you call reset again, then it goes back to 0 again. So that is how the functions will work. Then there are some constraints here. It says the value of init is arranged between -1000 to 1000, and the number of calls can be either 0 to 1000, and each call can either be increment, decrement, or reset. To successfully tackle today's challenge, we'll need to leverage our knowledge of functions, objects, prefix, and postfix notation, all of which we have discussed in the previous sessions. So let's approach this challenge as an opportunity to reinforce our understanding of the learned concepts. Like in function, you need to know how to declare the basic syntax of a function using the function keyword. Just to remind you, it's just function, then name of the function, name of function, like that. So this is how you declare a function. You have to know that syntax. Then you have to know the anonymous function that has no name. So this name is not there, but you assign it to a variable. So this you treat functions as first-class citizens, where functions are treated like values. So you can assign functions to variables. That is called treating function as a first-class citizen. Then you have to know the arrow function syntax, which there's no name, and no function syntax, and there's this arrow. All of that we already discussed. Then objects, you have to know how to declare an object. You can say you have to know how to declare an object. Like you can say, let me call an object. We talked about person, like that. Then you use this curly brackets. Then you put a key and a value. So that is how you declare an object. Then if you want to add more than one key, you can put a comma and add another key and value there. And to access them, you can use the dot notation. First, you'll say like person, then dot, then the name of the key to access the value. So that is how you access values. And you can also use the bracket notation, this bracket notation. That will also work. And we already talked about that in the previous sessions. Then about the postfix and the prefix. So I said prefix notation, the operator is before the variable. We saw this one and this one, and we saw the difference, how this one differs from postfix, that looks like this, or if you use the decrement like that. So this is called prefix increment, this one is prefix decrement, this one is postfix increment, and this one is postfix decrement. And we saw how we said that this one, it increments the value and returns the new value, but this one increments the value but returns the initial value. To learn more about these things, you can check our last video. We talked in detail about all these concepts. So these are the concepts that we'll use to solve today's challenge, and I believe by now, if you're following the course, you already know them well. So without much ado, let's go to the solution of today's challenge. So to solve this challenge, you're supposed to create a function called createCounter. I'll use the anonymous syntax. So I'll say createCounter. I hope I got the spelling right. Then I'll use the anonymous syntax. So I'll say function like that. So I've created a function called createCounter. Then I told that this function should accept an initial integer int. So it will accept an integer called init, not int, init, like that. Then it should return an object with 3 functions. So the return type should be an object, so it should return an object that has three functions. So I can create the three functions. So I can create them up here. So the first function is called increment. So I'll create the increment function. So I'll say function increment like that. Then I can duplicate this one 3 times. 3. The next one is called decrement. So I'll just change the name to decrement. Then this one is called reset. So I'll just change the name here to reset like that. So yeah, now I have my three functions, and I have to return them. So I'll return here. So I've said in object you have to put key and value. It should be key and value pair. So it should return increment. That is the key, and the value is increment like that. And the next one I'll return decrement, and the value is decrement like that. Then the last one I'll return reset, and the value is reset like that. So now, since I have my functions and I already returned them, now I have to implement these functions. So it says that decrement does not take any parameter, so it will be that way here. Do not put anything here, but it has to return the current value. It has to increase the current value by 1, then return it. So this init is the value. So I have to take this init, I increase it by 1, then I return it. So in layman's, just init, I increase it by 1, then I return it. Something like this. So like that. But since you know about the postfix and the prefix, you can do, instead of saying init plus 1, you can do init plus plus. But since you know about the postfix, you know that if you say init plus plus, it will return the old value. But as you don't want the old value, you want it to return the updated value. That means we'll use the prefix notation like that. And I believe you know about the prefix notation. It should be that way. Then the same things happens with the decrement. So decrement, it will take the value, then returns it reduces the value by 1, then returns the new value. So here you can return minus minus in it like that. Or if you want to use it's called the postfix notation, you first have to say init plus plus, then the next line is when you return. But this is too many lines, so I'll just maintain the previous one. I'll just maintain this one to save the number of lines that I'll use. And we have said that this function here has access to this init outside here because of the power of closures. And we talked about closures in almost the last 3 videos. I believe by now everybody knows about closures. So yeah. So for the reset, you want to return the initial value that was here. But now since you're changing this value, you cannot track the initial state. So you have to create a member variable here to track the initial value first before you update it. So I'll create a variable here. I'll call it, I'm very poor in names. Maybe I can just call it val. Then I can assign it to init. So after taking this initial value here, I assign it to a variable called val. Then this val is the one that I'll be updating it. This val is the one that I'll be updating it here and here. So val is the one that I'm updating it. Now that means that I still have the initial value stored in this variable init. So I can still track, I can still have access to that init variable here. This value is just a member variable. So here in the reset, I'll just assign val to init. Then I'll return the result like that. So yeah, I believe that is the solution to the challenge, but you can just confirm. Let me use these test cases here. So the first test case is saying that we call this function with the value 5. So I'll call the createCounter. So I'll say createCounter. Then I call it with the value 5 like that. But I have to assign this to a function. So I'll assign it to the counter function. So I'll say const counter like that. So this will be like the it will be in object-oriented programming. This will be like the class. Then this will be the object. I think we talked about how to relate these ones with the object-oriented programming in the last video. So you can check that to see how we solve this challenge in the last video. So if I want to access this increment, I can call it with the counter method. And we saw that to access a property in an object, use the dot syntax. So I'll use the dot syntax. Then I'll say increment. I'll call it with the increment. Then I call it with the reset, then decrement. I'm using this example one. You see, it's called with the increment, then called with the reset, then called with the decrement. So there was increment, then I'll call it with the reset. So I'll remove this. I'll call here reset like that. Then here I call it the decrement. Yeah, but I have to log all this so that I can see them in the console. So I'll log this one. Just log it. Like that. Let me just copy this so that I can paste it in all the three. Then I close the curly bracket here like that. So yeah, I can now I'll run this code to see if it will return 6, 5, and 4. So let me run the code. Fingers crossed. You can see indeed it returned 6, 5, and 4, just like what our output expected. So if you use the second example, it's called using 0. So I can just change this value here to 0. Here for createCounter, I can change this value to 0 like that. So I may save this code and run it again. And you can see it's 1, 0, and -1. But we call it with, let me just also call it using the correct order. Here you should call it with example 2, increment, then increment again. So I'll increment it twice. Then decrement. So I'll move this one up, decrement, then reset twice. So I'll call reset twice like that. So now let me just kill the terminal and run it again. And you'll see that indeed, let me just scroll up. You can see now indeed our answer was 1, 2, 1. You can just confirm with the example there. Where is it? It's here. You can see 1, 2, 1, 0, 0. 1, 2, 1, 0, 0. So that means that our solution indeed worked and passed all the test cases. So the next thing that you can do maybe is just to refactor this code to be even better. So let us do that. First, we'll start with this object here. So the new ES6 syntax supports if a property has the same key, if the key and value of a property have the same name, you are allowed to use just the key like that. You can remove the colon and the value. So you can do that first. So that is what I'll do to make it more concise. So yeah. Then also in our functions here, we can use the arrow function syntax. So I'll just remove this function here. Then I'll store this in a variable. So I'll call it const increment is equals to, then I'll put the arrow function syntax like that for all of them. Like that. So yeah, believe this one is that way. So it's over. Then we have learned that if If an arrow function has just one statement, that is the return statement, you can put it in a single line like that, in one line, and you can remove these curly braces. So I'll do that for the remaining one. I'll remove the return statement and the curly braces for all of them like this. So here it should be is equal sign here. Here there should be an is equal sign like that. So yeah, so I believe now our function is concise and it still works. You can just run to confirm it still works. So you can see, let me just confirm if there's an error. I think it's fine. So let me just save this code and run it again. So yeah, you see it ran and it gave me the same results as before. 12100, 12100. So yeah, that is it for today's video, guys. See you in the next video. Peace out.